morning, everyone, and welcome back after the coffee break. Well, I'm on camera. Nice. We paid this good money to get a time slot after coffee break because it's always the best time. So everybody's fully awake, after the breakfast. So you may be wondering why I'm carrying a weapon. Yeah, so I put it aside, not to cause any threatening situation. Yeah, this is just something we are promoting for rotomotors. We'll help you guys out to make the best product. And today I'm just going to talk one part of the rotomolding, demolding. So let me just crack on. Oh, okay, I'm looking for this. Yeah, and in this presentation, I will talking about first the most challenging stage of rotational molding, and then we will tackle this point from 4 different angles, like the tools, release agent, also the rotomolding process, cooking, cooling, etc. And of course, Matrix Polymers is a material supplier. We do have a quite wide range of plastics we can burn for fun in rotational molding. Yeah, I'm going to talk a bit more about it. And we will have a quick conclusion with some funny videos from somewhere else. Yeah, just to give you a bit broadcast so you don't run away. Yeah, in 10 minutes, I'll be keep talking in the next half an hour. Yeah, maybe 45 minutes if I have time. Yeah. All right. So, well, you've been doing these things on a daily basis. You're loading the powder into your mold. You send the mold in. You cook the material, and then you cool your mold, and then last you take it out. So I just put some difficulty levels here. So like a minus, plus, or question mark. So we have a lot of operators in this room. So basically, I'm only saying in my humble opinion, because I've been traveling around the world. European molders, Australian molders, New Zealand molders, Chinese molders, Southeast Asian molders. So most of the rotomotors are worried about something goes wrong during the process. Then they couldn't get the product out quick enough. So which means they need to delay the production, causing more, issues. So in my humble opinion, I put unloading as the most difficult part in the rotomolding stage. Well, some molders, they use good process control, so they can take their product out, no problem whatsoever. Yeah, so that's a target we try to hit. And okay, without further ado, I'd love to show you a tricky situation. Yeah, in case people at the end of the room don't see the product, it's here. Yeah, you only see a part of it. So basically, this is a photo my colleague took a couple weeks back when he was in India. We are working with a rotomotor locally to make a new product. Apparently, this is a new design of the mold. It's the first time these guys are cooking our material. So we made some mistakes during the processing. So the product, unfortunately, kind of stuck in the mold. Due to the size of the mold, only 6 people can go around it, take it out. So as you can see, we have operators here, production managers, designer, business owners. Even my colleague who took the photo joined this force later. So there were like 20 people. They do 6 people, 1 run. And all 20 people tried, failed. So they end up drill 2 holes of the product, put a rope around, take it out by a forklift. So they barely damaged the product and the mold. So this is a scenario probably everyone in this room has encountered daily, weekly, monthly, yearly, never. Oh, I hope that's the less the better. Yeah. So when these things happens, people may think this. Oh, I hate this tool. Yeah. Oh, I hate this product. Oh, I hate the material supplier. Oh, I hate my life. Yeah. Why I end up in rotomolding. Well, I'm just saying I don't hate my life. Yeah, I don't hate the industry. Yeah, this is a fantastic job. I can travel around the world to see different molders, watch them in trouble. Yeah, and try to help them. Yeah. So when things calms down a bit, the rotomotors could think, Okay, did I apply the release agent? Okay, did I apply the wrong type of release agent? Or could I use a different type of release agent? Then I don't have to apply every single time. And furthermore, did I overcook the material? So basically, you could tell by smelling at the plastic. We all know if you burn a bit the plastic, they are very sticky, so you will have problems. And well, sometimes people just simply forget to remove the metal insert. You unscrew it, the product come out. And so far, we all understand, if we have a standard procedure in place, like a cooling, okay, you turn the fan on after 10 minutes, and you turn the water spray on after 15 minutes, or use internal cooling system, etc., etc. So sometimes people just in a rush, they didn't follow it. The material came out, or the product came out fairly hot, so they can be sticky. So maybe you just wait a bit longer, things will sort it on its own. Or another way around, if you cool it too much, the product just gelled up in the mold. Well, you probably need to heat it up to take it out. Yeah. So that's a procedure we need to follow. The cooling procedure can really contribute on the demolding difficulties. We have a couple cases to share with you later. And of course, materials, if you use the mold to make a softer product, so you can always take it out. If you switch to a stiffer product material, they can be a bit stuck in the mold. Yeah. So choose the right material. The right material will lead to good demolding stage, or another way around. So we need to be careful. Okay, so I put up a few sentences here after talking to my colleagues in sales department. Yeah. So basically, I gathered the following sentence from a rotomotor, actually. So it's all about how much you have done before putting the powder in the mold. So the later cooking, cooling is already programmed. So if you have done something correct, the demolding part will be easy. If something goes wrong, oh, hallelujah, yeah, best luck. You can spend 20 minutes cooking, 30 minutes cooling, 5 hours demolding, yeah. So we don't want that to happen, yeah. We want 2 minutes demolding maybe, yeah, or even quicker. Okay, so from the product design point of view, I dare to say, the rotomotors, the product designers, the material suppliers should be getting involved in the early stage of the rotomolding product. We know our materials, the rotomotors knows how to take it out, disassemble it. Of course, the product designer knows what they want, the end user knows what they want in the market. So we can have a fantastic mold made, good internal surface finishing, they can make a good product with the right material. When the things come to demolding, maybe just, the designer didn't realize, well, the operators need to work on some hot stage, take it out, so they can really slow down the situation. I've seen a very nice product made in New Zealand a couple months back. It's a really fantastic feeding systems. The mold and the product all designed beautifully. It just happened, they didn't really think about the operator's point of view. So the operator has to really jump on it, spend half an hour to take the mold apart. So they wish they could have been involved in the early stage to make their life easier, and they can make more product per shift. So that's a kind of win-win situation. So furthermore about the mold design, so I dare not to comment too much, just to think about some cases like if you have undercut in your product, you would love to design like this, so the product can come out like that. If the undercut design like this, so the material shrinks, they will just stuck in the mold. So things like this will really help the rotomotors to do their job at the demolding stage. Yeah. And further up, this hot or cold spot in your mold. I only have half an hour here, so I cannot tackle too much because every point in these slides come up with a story. Yeah, so I can spend 2 days talking about the stories of my roto wandering. So forgive me if I just be very brief. And I was in New Zealand last week conducting Crosslink trials with a rotomotor. So that's the first time these guys are working on Crosslink. So you know the Crosslink material is stiffer and stickier than the conventional linear low density polyethylene. So which means they need to demold at a different fashion. So basically for that particular mold, they have demolded like the standard 90 degrees. You know, they use an infrared gun to measure the mold temperature 90 degrees, take it out. Ooh, they find this thing is really sticky. They can't really shake it out. So then we kind of use the infrared gun to check the different part of the finishing product. We noticed one part is 10 degrees hotter than the rest, just because that part of the mold was slimmer. So the kind of thicker wall thickness. And then what we did is just wait 20 degrees later, you know, the temperature drops. The things just come out magically. At that time, we measured the mold temperature is only 60 degrees. So hang on a minute. So basically, does that mean we need to do 60 degrees for that particular product? Yeah, yes, I think that's the answer. You know, you work the same mold, you change the material, you just need to work on a different demolding temperature, just because this product has hot or cold spots. Things could go another way. If the product kind of demold at 60 degrees, maybe the shape has already fixed. If it could stuck in the mold, it will stuck further. You could really heat up, you know, demolding at 110 degrees, yeah, with a bit gloves protection when the plastic is soft. David has mentioned a couple occasions in this workshop, you know, the material, the boiling point of most rotomoldable plastic is 110, 120, which means below 110, the material is already in a solid stage. So in theory, you could take it out when it's hot. Yeah, just to be careful, don't burn yourself. And when the plastic is soft, it's always easy to demold in theory. But sometimes, if I keep mentioning the Crosslink again, when it's hot, it's really sticky. You rather wait a little bit, let it cool down, let the shrinkage does its job to push the plastic out. Yeah. Okay, sorry, I did a bit, watch my time now, yeah. Okay, so, okay. Finally. What's this for, guys? Yeah, and we give away free. We have a video to show you how to use this beautiful orange stuff. Yeah, so this is something to help you to clean your mold. The idea is you need a plastic to clean your mold, to remove the remaining plastics, not damaging. You just want to damage the plastic remaining on your mold to remove that, but you don't want to causing any damage in your mold because that's your best mate. You better take good care of it. So if you clean your parting lines carefully, you will control the demolding challenges. Yeah, so we have a couple left on our standard. I recommend every single operator need to have a couple of them. Yeah, you cut in a different, trim it in a different angle, and you can use it for different tools. Yeah, it looks cool. Carry on with you. Yeah. Okay, so of course, you know, regarding these venting tubes, I think this is a very straightforward situation to imagine. If the venting tube blocked in the cooking cycle, so the air was trying to get out, but you block the venting pipe, the air will get out somewhere else, the parting lines, so you're going to have a lot of flashes in your finishing product. If the venting pipe was blocked during the cooling cycle, so the air was trying to get in to cool your product, you just block the vent, so the air will get in from somewhere else, like the parting lines, so that's where the blue holes happens. So which means, in which case, you could have causing some deformation of your finishing product. You deform your product, you will have trouble to take it out anyway. Well, metal insert, you know, unscrew your metal insert before you take your product out. Yeah. And regarding the demolding stage, regarding the demolding procedure, you know, different product needs to have a different procedure. You know, we need to keep updating it. Sometimes you use a different material, sometimes you use a different metal insert, etc., etc. Okay, a video to show you. Okay, sorry, this music was done by my New Zealand colleague. He has a little bit rock and roll taste. Yeah, not my cup of tea. Yeah. Okay, well, this is the second angle of the demolding. Yeah. So the tools part, it's one angle. Let's talk about the mold release and how the mold release could contribute to the demolding part. So in my humble opinion, we split this release agent into three types: internal lubricant, semi-permanent, or the permanent coatings. Internal lubricant is something we added in as a supplier in our manufacturing process. And I know some molders are using them as a processing aid. After loading the powder, just whack it in a few grams or a few 100 grams of this magic powder to hope the product will come out smoothly. It does work in some molders, not every single cases. And I've seen a rotor molder keep using this magic powder. So the internal lubricant comes as like a fine powder, a couple 100 grams per 100 kilo short weight. So nice and easy. And he has a sister company working on the same product. So I take a 30 cubic meters water tank, for instance, 500 kilo short weight. Molder A use 200 grams perfectly. They don't need to, I was told, they never apply any semi-permanent water or solvent-based release agent in their mold. So just powder, 200 gram powder, magic powder in. And his sister company working on exactly the same mold, same shape of mold. Yeah, maybe made the mold is different material or the machine is different. So they need to use 5 kilos, 200 grams up to 5 kilos, the magic powder to reach this semi-permanent release agent free situation. So after a couple of weeks, the production manager of the other side decided, okay, well, we go back to our water-based release agent. Yeah, it took us time to apply, but at least the cost is done. Yeah, we can't afford to whacking every 5 kilos into every single water tank we're making. So this is just ridiculous. Yeah. So this is the extreme case to show you. It works on someone, it doesn't work on someone. Yeah, it might be the same product. So case by case, guys. And we, as a supplier, in the position to adjust our lubricant level in our powder. So depending on your lead, you could come to us, say, look, I like more, your plastic is sticky. Or I don't like more because your plastic is runny, or we have a demolding, deformation issue. Yeah, so we're happy to help you out from that point. And this is the best part of this presentation. Actually, we may causing some argument here. So guys, if you are working on water-based release agent, could you raise your hand? Okay, less half of the room. Solvent-based, please. Okay, this is an even case. Yeah, yesterday we have more water than solvent. Yeah, I know there are advantages and disadvantages of how to apply. Yeah, we're gonna come to that later. And the last one I could just quickly explain. Funny enough, Lisa showed me a very nice mouse coating photos 2 seconds ago. So this permanent coating is just like a layer of material, could be Teflon, coated in the internal surface of the mold. So what that means is like you will never need to, in theory, never need to apply mold release. So the plastic will come out smoothly, beautifully. So depending on the lifetime of the permanent coating, you may need to apply twice a year. Just the mold supplier, like a mouse from Germany, they will coat it for you. At the meantime, I noticed that some molder expecting, suffering encountering this pre-release of their product if they are using permanent coatings. Yeah, so this is something you could look at, but just be a bit careful because you have some disadvantages as well. Okay, guys, without further ado, I put up this. This is the argument slides. Yeah. All the places I've been to, Auckland, Brisbane, Sydney, people just agree for the disagree here. So solvent-based mold release agent and water-based. Application refers to how you apply it. And I have a video to show you how to apply water-based. In my humble opinion, I think water-based release agent is harder or more sophisticated to apply than the solvent-based. Solvent-based is like you spray, you apply, you wait the solvent to evaporate on its own at ambient temperature quickly. And water, you need to get the water out. Yeah, so you can bake it, you can wait, or you can burn the mold. So it's a little bit time-consuming, relatively. And the cost-wise, these two types should be in the same range. And the performance-wise, both good. The water or the solvent are just the carriers of the mold release part. So once you apply them, they both work. And usage, I know people wouldn't agree. So depending on just up to our experience, we realize the water-based lasts longer, let alone the environment and the safety discussion. So people think, organic solvent is not that environmental friendly. Safety-wise, you apply the organic solvent. Some people, like me, if I smell too much of the organic solvent, I feel a bit dizzy. Just like I had a couple of beers, my face could turn purple, In our company policy, if we have a beer or drink alcohol, I can just go home, have a day off. Yeah. So I don't know what's the rules here. So if that strictly applies, those guys who raise your hand just need to go home after half an hour after applying the organic solvent. Yeah. Again, this is just based on our humble opinion, to share with you what's the difference or the challenges between solvent and a water-based release agent. And as a material supplier, we are globally distributing the water-based release agent made by Stoner. We have a couple samples in our stand, and you're welcome to have a look, have a chat with me or my colleague Ashley. Yeah. So I have a small video to apply, to show you how to apply the water-based ones. So the concept is apply the water-based evenly. And if you can, bake it in the oven, or we use open flame. And if it's durable for a new mold or for a new product, repeat. Yeah. But again, just the takeaway message is you don't have to apply the mold release every single run. So between two applies, I have a record high number from a tank maker. Yeah. He told me he's making 150 tanks per apply. So he's cooking these 5,000 gallon plus tanks, not really 500 liter in the small tanks, a big one, open flame in Queensland. And my numbers will be between 20 up to 150 then. So without further ado, let's play the video. So this is the ambient temperature, 25 degrees. Apparently, this video was taken in Northampton quite a few years back, UK. So 25 degrees was a hot day in Northampton. Yeah. Normally we have, 5 degrees. Yeah. So what we did, the first part is we apply a little bit too much. As you can see, the details, we have a lot of water marks, liquid. So which means we didn't really bake it. We just apply and use straight away. And the small molding is the standard hexagonal shape. The short weight is just 1 kilo. Yeah, we can see these waters remaining on the mold, also on the finishing product. So that's something we try to avoid. Don't do it. The ideal way is you apply the release agent in the mold, and you send the mold empty into the oven, and you bake it. I know sometimes if the water tank, for example, mold is too big, what's the point to send it back in or turn the fire? So you can really just let it dry one night before, or you use open flame to burn the external surface just to evaporate the water. But the idea is you need to approach 60 degree plus of the mold, so the water will go out. And we using some tissue paper to make sure, there's no liquid stage left, phase. So all dried out. So the mold release are applied evenly. And the finishing product came out much better. So we don't have the water marks, and the release nicely. So just be in your mind, guys, you need to apply the mold release only when the product came out a bit sticky for the previous run. You don't have to do that sophisticated cycle every single time. Yeah. So you could get 20, 30, up to 150 product out of the mold before you apply again. Yeah. So that's the beauty of the so-called semi-permanent release agent. Okay, finally, we reached the breakfast domain. Cooking and cooling. Yeah. So this is a third angle. The rotomolding process could contribute on the demolding stage. And you just don't worry about this. Yeah. So let's look at the photos. Yeah. This is instant noodles. Yeah. This is eggs on toast. This is just some metal plates. Yeah. Okay, well, still with you. Yeah, good. This consider the fact we are cooking plastics, so we change the plastics from solid to liquid, and then change it from liquid to solid. So basically, what happened to the plastics are they are folded. Well, sorry, at the melting state, they're just like noodles, spaghettis, runny. When they cool down, they tend to fold themselves. That's the nature of the polyethylene we are cooking. So the way they fold, quite similar to the instant noodles. I'm not sure if you guys ever tried instant noodles. Yeah, the Korean ones, Chinese ones, Malaysian ones, Indian ones. Yeah, good. Tim is a master. Yeah, and well, I'm the master because I went to Sunnybank in Brisbane. Oh, I found a whole collection of the instant noodles around the world. Yeah. When I was young, we only had 1 or 2 choices. Now I have like 20 to 30 choices. Even got some Australian one, yeah, the steak one, very nice, yeah. So I know it's not that healthy food, but sometimes you're busy, particularly the life in Matrix Polymers. Actually would agree, yeah. You don't have that much time for lunch, yeah. Best part of 5 minutes. Hot water 2 minutes, instant noodles, yeah. Sorry, I just a little bit carried away. So the solid stage of the plastics look like a folded instant noodles, yeah. Of course, we always say polyethylene is semi-crystalline. What does that mean? These instant noodles behave like the rigid part. Between them, we have this so-called amorphous region. They are like soft noodles. Use the best imagination, eggs on toast, or the, sorry, Ashley, what did you have this morning? Avocado mash with toast. Yeah, the toast is the rigid part. Things between the eggs is the soft part. So that's why plastic is rigid and also soft, yeah. Of course, if you go to metal is just rigid. You can't bend it just because metal has no amorphous phase. And the question comes to this, well, why do you show this? We are in a plastic industry. Why you show a photo of metal, yeah. And Blois knows this is not a metal, yeah. This is a plastic, yeah. And basically, under microscope, the rotomolded part looks like a metal, yeah. But again, between this crystal shape, we have this amorphous part. So just to show you in a better way, we have a couple of photos. So look at this cross-section of this particular part. That's a crystal shape. Yeah, you can see it with our naked eyes. We don't have to watch under microscope. To achieve that, you just need to cook a 5,000-gallon plus tanks in a standard way, cool down gently. If you can break that tank, you will be able to see it. David, do you still have your samples around? Yeah, good. Yeah, and his sample is just undercooked, but you can see these crystal structures. If you see some air bubbles, that's because the sintering stage, i.e. the cooking stage, is not properly. So that's why you have air bubbles. But again, the air bubbles, the pinholing coexist with crystals because these things just created by the beauty of rotational molding. We cool down our product slowly. Yeah, we can't really fast enough. Of course, the internal cooling, water spray can speed up. But again, compared to the injection blow molding, rotomolding is relatively slow. So in this particular case, this is a part of a engine-powered boat made in Scandinavia. The short weight is in the range of 500 kilos. They basically put 2 Yamaha engine at the back. They can run fast. So this material density is 935, just like the Quinol 705 material. And for the finishing part, I measured because it breaks. Yeah, they want to understand what went wrong. It seems not undercooked by why this thing has such a high brittle failure. So I took this piece, I measured the density, it's 955. So basically, think, hang on a minute, 935 is a perfect linear low density region, or we call medium low density. And a 955, it's, well, you're too excited, eh? Yeah, as a rotomotor, we are changing the properties of the plastic. We make a soft LLDP as rigid as HDPE. Well, actually, we actually turned it to HDPE. The crystals you see here is just because we cool down gently, slowly. So the plastics, the noodles, get a chance all folded like the instant noodles. We don't have much this softer flowing around amorphous phase left. So which means the density increased. You kind of concentrated the density. So the product becomes stiffer than the raw materials. And we also have a couple of other samples. This is from the Netherlands, a floor cleaner. You probably recognize the color already, yeah, but I have to say it's not because their product failed. Yeah, we were conducting a new project with them. So we changed the different cooking parameters. We end up have one part, brittle failure. And of course, that's because the density is high, because we cool down too slow. Another photo here, these crystal structures indicate, the big, crystal shape. If we cool down our product slowly, you will be able to see that only in rotational molding. Yeah, so we are in a fantastic rotomolding industry. So, but of course, you love to use this wisely. If you want to gain the stiffness, cool down slowly. If you want to keep the toughness of the plastics, you either start from a lower density one, so they don't end up too high, or you just cool a little bit faster. And you can get these crystal structures smaller, more regulated. Yeah, so you can still keep the toughness. So stiffness and the toughness, your choice. Yeah, just by control the cooling part. Okay, I keep talking about the cooling here. So again, this is another thing we are facing in a daily basis. We know the plastics we are burning or we are cooking, they do shrink. Well, we enjoy the benefit. If they don't shrink, well, hallelujah, you can't take it out of the mold. But if we manage to cool regularly, regular cooling will make the plastic shrink in a regular way. So you design this shape, just a little bit smaller, 2%, 5%, perfect, take it out. If we didn't manage to regularly cooling our product, you may have some warpage. So the product could stuck in the mold. Yeah. Oops, sorry. Here is a typical case. I'm not commenting on the mold or the parting line or the flanges. Yeah, only look at the product, just because we didn't cool it down the product regularly. So we have irregular cooling, so the wall thickness distribution is not that great because we didn't cool down regularly, so the crystal shape. Consider the noodles, eggs, toast and eggs ratio are not right, not even, so they deformed. So the shrinkage is not, constant, so this is called warped. Think about it, if you have a product a bit more sophisticated than this, they could have just stuck in the mold, yeah, causing demolding difficulties. So, yeah, okay, I'm done about the third part. Now, finally, I come to this. Okay, I better be quick. Materials. So this is the fourth angle to look at the demolding challenges. And I put up a list of the materials we're supplying, and I'm going to explain a little bit of each one of them. So the first one is beautifully linear low density polyethylene. It dominates 95% of the market in our industry, so which means 95% of the product and the material we are using are polyethylene. Yeah, so it is a main force. Luckily, the demolding challenge is just so-so and not that challenging. We always take it out. If we get to the right cooling, mold release agent level, yeah, or good cooling demolding procedures, we will be able to take it out. Here is a photo of a wood box. This is actually made out of polyethylene in Germany. So with a good combination of the plastics, colors, pigment, the mold design, you can actually make a rotomolding product looks like a wood, lasts longer than a wood. Yeah. So I'm just showing off something we are making. And there's a nice video coming. Yeah, guys, stay with me. Yeah. Okay. A couple of years back, I was joking. That was Blois on white water, and he denied that wasn't him. Yeah. So maybe another gentleman. So this case, the material is a higher density polyethylene. Yeah. So think about it. The plastic is stiffer. So basically, if you use a stiffer material in the same mold, they can be a little bit unforgiving on the shape. So in the past, if the material is soft, you can just pull it out. If you have a stiffer material, they can just hold a bit longer. Yeah. So that's why I'm indicating, the HDP has a higher level of demolding difficulties, challenges compared to linear low density. And this one is a bollard, so a traffic cone. Basically they put a light under this, so people knows where to turn. Yeah. So sometimes in the weekend, some car will run over it because these guys hand over. Yeah. So this is a part photo taken in Manchester. So the idea is when car hit it, yeah, the plastic can go back to its original shape. So it's a very soft material. We call this elastomer. And basically, elastomer is a combination of the linear low density with some plastomers. The idea is it's rotomoldable. It's just soft. And think about the rotomolding process. The elastomer could consume more release agent just because they are stickier. But in the later case, you can always push, take it out. So it is slightly more difficult than ALLDP, the conventional man-force polyethylene we're using, but not that bad. This is a bad boy. Yeah, Crosslink. This is a portable diesel tanks we made in Germany. It's the short weight roughly 10 kilos, 15 kilos. Yeah, I remember this project. I went there. These guys never molded a Crosslink before. And during the rotomolding process, they keep smelling something strange. They say, oh, have we burned the material? I say, wow, actually that's a good sign. You smell something means Crosslink happened. And yeah, that demolding was a nightmare the first time. So the concept was because this material is stickier, because the Crosslink nature stickier, stiffer, so they don't forgive it. Yeah, so they keep in the same mold. So it took us a lot to take it out. So we need to use the right mold release, right cooling procedure, or right demolding procedure to process Crosslink. Okay, further up, polyamide. This is a Kawasaki tank. So Kawasaki is a Japanese motorbike brand. We have a couple molds from them, from their OEMs, the old mold. So we're happy to use the Kawasaki tanks to mold some new product. Polyamide is also called nylon. So it's a material really added value for fuel tanks application. It's a rigid material. So we find it's challenging to demold compared to linear low density. Yeah. That comes to the diamond on the chrome. Yeah, the most challenging one. 3-star, 3+, polycarbonate. This particular mold is made in New Zealand. Yeah, I took a photo just to show you how transparent this plastic is. So just so you know, this plastic, they are not toasters. They are not toast. They are not noodles. They are just eggs. These things has very limited level of the crystallinity, so it's just amorphous. So basically, a takeaway message is, once you see a transparent plastic, actually it's not crystals. Crystal clear, no. Amorphous is clear. Okay, well, I don't have too much explanation on that. I could spend half an hour, but I only have 2 minutes left. Just remember, amorphous plastic is transparent. That just gave us a good opportunity to, introduce added value product, polycarbonate. Unfortunately, the demolding stage is challenging. Think about it. This thing is stiff. This thing is sticky. Also, guess what? They don't shrink because it's amorphous. So that gives the challenging of it. And the last bit is a PVDF, which is a very added value plastic as well, and it's as good as demoting part, as good as LLDPE, well, at the very least. I like to finish up with a video, yeah. Water tanks, yeah. These water tanks are in India, yeah, so it's not in Australia and New Zealand. Yeah. So these things don't happen, yeah, just because Matrix Polymers is doing something here. Yeah. We'll let you know later. Yeah. So please come to our stand. You know, we do have some leads and strainers for you. Yeah. Okay. Finally, conclusion. So demolding is the most challenging part of the rotational molding, in my humble opinion. So please, guys, use release agent. It will help you out. Yeah, water-based or solvent-based or the internal lubricant. Choose the right one for your application. And the tools, yeah. Don't forget to pick up yours, operators. Yeah, only free for today. After today, you will be charged. Success, good. Yeah. Don't overcook, you know, please, you know, you burn the plastic, and cool evenly. And you know, cool evenly, they will come out evenly in one piece, nice and easy. And the material choices, of course, softer material should be easier to demold, because one way or another, push it in, take it out. Once you have a stiffer material, just be careful, you know, get to the right cooling or the mold release. If you have a stiff and a sticky, yeah, best luck, yeah. So, well, I'm still thinking the Crosslink nightmare I had last week in New Zealand. Oh, God. I was talking to my colleague. I said, okay, if the second one didn't come out on time, yeah, we're both wrong, yeah, away from the molders, yeah, before they keep us overnight, yeah, to demold, yeah. But luckily, we get it out just by cooling down 20 degrees later. So just, guys, if something goes wrong, the product stick, don't worry, yeah, leave 20 minutes, well, 10 minutes, let the plastic cool down, it will do its job, yeah. Or another way around, heat it up, get the plastic softer, take it out, yeah. Okay, that will be the end of my presentation. Thanks a lot for your time, guys.